Hey guys, today we're going to learn about solving equations using the distributive property and combining like terms. So looking at this example, using the distributive property to rewrite the product, you're going to take the number anytime it sits on the outside of a parenthesis, a number or a letter, you're always going to distribute it. When I say distribute, that means to multiply. So you're going to take this 5 and you will multiply it by the x. So 5 times x is 5x. And then 5 times the second term of the binomial, and that's a positive 2. Remember that sign goes with it. So 5 times positive 2 is a positive 10. You cannot put those two things together. They are not like terms. So this is a good review of what we did in the last section. Example number 2, again, you're going to take negative 8 times the first term, which is 2a. That gives you negative 16a. And then negative 8 times the second term. And in this case, the second term is a negative 3. Negative 8 times negative 3 is a positive 24. Again, you cannot put those together because they are not like terms. So we're going to use that thought process today and look at example number 3. In example number 3, you have an equal sign, and that means we're going to draw a line down that equal sign just to keep things balanced. So the very first step that you're going to do when solving a problem is to try to get rid of those parentheses. In order to get rid of the parentheses, we're going to do the distributive property. So we are going to distribute 5. Anytime it asks for what's the first step, if it looks like this, you're always going to distribute. So when we distribute 5 times x is 5x. Remember, when we're drawing those arrows, it means to multiply. 5 times the second term, and in this case, the second term's a positive 2. That gives you a positive 10. And then we're going to bring down everything that we didn't touch, which is the equals 25. Now, the next step in this process is we're going to get rid of this plus 10 because our ultimate goal is to get the x by itself. And right now, attached at the hip is the 5. So we need to get rid of everything that's not in this orange square, which is the positive 10. To get rid of that positive 10, we have to do the opposite, which would be to subtract 10 on both sides. When we subtract 10 on both sides, this side cancels. Then we have everything that's in the orange box, 5x, and then it's going to be equal to 25 take away 10 is 15. And so what we did there on that second step was the subtraction property of equality, and we will subtract 10. The third step that we're going to do here, again, our goal is to get this x by itself, so we got to get rid of the 5. Right now, 5 is being multiplied by the x, so we're going to do the opposite of multiplication, and we are going to divide both sides by 5. When we divide both sides by 5, the 5's divide away. 5 divided by 5 is 1x, which is what I wanted. And that's going to be equal to 15 divided by 5 is 3. That is how we solve example number 3. Now, to check your work, by the way, a fancy way of seeing if 3 is a solution, they may write it like this. 5 parenthesis x plus 2 is equal to 25. If they put that semicolon there and say 3, that all that means is x is equal to 3. They want you to check your work by plugging in the 3 where you see the x. So that's what I'm going to do down here under check your work. 5 parenthesis equals 25. Inside that parenthesis is an x, so I just found x was 3. I'm going to put a 3 there. Now, using Desmos, you can pull it up on your Chromebook, which is the way that you're going to have to do it because you're not allowed to use your phones. And as I do that on my phone here, I'm going to type it in exactly as I see it. 5 parenthesis, 3 plus 2, closing my parenthesis. Oops, I put a plus sign. I'm sorry. Or I put a minus sign, and it's supposed to be a plus sign. 5 parenthesis 3 plus 2, so that's exactly as I see it. It's equal to 25. And it is actually supposed to be equal to 25, so that's how I know I've got the correct answer, and I'll put a check mark above it. All right, next example, example number 4. This time you're going to distribute out a negative problem or a negative integer. So my very first step, again, is to get rid of those parentheses, so I'm going to distribute. When I distribute, I'm distributing a -2 to every single term inside the parentheses. So -2 times 3x is a -6x, and a -2 times a -1 is a +2. That's equal to 26. The next step that we're going to do, again, the goal is to get the x by itself, but right now it's attached at the hip to the -6. So I need to get everything in that box by itself. That means I got to get rid of this +2. To get rid of the +2, the opposite operation is -2. So that's subtraction property of equality. So I'm going to write over here, the next step is subtract 2. When I subtract 2, +2 minus 2 is 0. I'm left with everything in my orange box, so I'm going to bring it down, -6x. That's going to be equal to 26 take away 2 is 24. So step number 3, again, -6 is being multiplied by the x, and our goal is to get this x by itself, so I've got to get rid of that multiplication by dividing both sides by -6. That gives me x is equal to -4. And that last step that I did, I divided -6. Now I'm going to check that work. Again, the fancy way that they'll show you on your assignment, it will look something like this with a semicolon and then a -4. All they want you to do is plug in that -4 where you see the x. Remember, when you plug in things, you're going to want to use parentheses. So I have -2 parenthesis 3, then my x minus 1, close my parentheses. It's supposed to be equal to 26 when I type that in Desmos. Where I see the x, I'm going to put in parentheses my -4 because that's what x was actually equal to. So as I type this in, -2 parenthesis 3 parenthesis -4, close my parenthesis, minus 1, close my parenthesis. Notice this looks exactly like this. It's supposed to be equal to 26, and it is equal to 26. That's how I know I've got the correct answer. Again, I'm just going to put a check mark over the equal sign, knowing that I checked it. In example number 5, anytime you see two fractions equal to one another, that does mean it's a proportion. And in order to solve a proportion, you're going to cross multiply like we did in the last section. But this time you've got a binomial on the top, which means it's two terms on the top. So the very first thing I want you to do when you have a binomial or two terms on either the numerator or the denominator, I want you to put parentheses around it. Then you can cross multiply. What that will do is remind you that you must distribute. So first step 1 is to cross multiply. When I cross multiply, I have 8 times 45, and I'm just going to write that out, 8 times 45, and that's equal to the other way, which is 9 times everything in that binomial, 9 times 30 plus a. And since I put that in parentheses, I'm going to continue to leave it in parentheses. And again, that will remind me to go ahead and do the distributive property. So the next step will be to multiply and distribute. Distribute 9. So 9 times 30 is 270. And 9 times this positive 1a is a positive 9a. That's equal to, and then 8 times 45. You can easily just type that in the calculator, and you're going to get 360. Now it's a two-step equation. So the next step I'm going to do is to subtract 270. Now the reason I'm subtracting 270 is because it's the opposite of a positive 270. This number is a positive 270. That is not because that's a plus sign. That plus sign belongs to the 9a. So positive 270 minus 270 on both sides. My 270s cancel one another. I'm left with everything that's on this right side, so that's the 9a. And 360 minus 270 is 90. So now I'm going to do the fourth step, which would be divide 9 on both sides. When I divide by 9, I'm going to find my A is equal to 10. Now I'm going to plug that in to my equation here. Now be very careful. This isn't as tricky as what you may think it's going to be. I'm just going to type in this side. 30 plus 9, or I'm sorry, not 9. A was 10. I have 9 on the brain. 30 plus 10, using my parentheses, all over 45. So I'm going to type that in my Desmos here. And because that's a binomial on the top, I'm going to push the divide sign, and then it's going to be 30 plus 10. And then see how that's on top already, and then over 45. It gives me a decimal here. Please remember, when you get a decimal, you can easily change it into a fraction by pushing this button right here. It does change it into a fraction. That fraction is 8/9. It was supposed to be 8/9, so I know I've got it right. So that's an easy way for me to check my work. That's the distributive property. Now we're going to talk about combining like terms. Like terms, remember, are terms whose variables and exponents are the same. So when combining like terms, remember to do it what it says. You do not change any signs as long as it's on the same side of the equal sign. So looking at example number 6 here, I have a 2x, and its like terms is a positive 5x. So when I put those two things together, I do what it says. 2x plus 5x is 7x. I do not do opposite operation because I did not go across the equal sign. Now the next one is a positive 3y and a negative y. Please remember that there is an understood 1 right here in between that negative sign and the y. So doing what it says positive 3 minus 1, that's a positive 2. And don't forget your y tags along with it. Now, you can't put those things together because they are not like terms. They do not have the same variable. So in this situation, you're finished because that was an expression. Now we're going to look at combining like terms in an equation. So we're going to actually solve for the variable in this problem. So if you go ahead and draw the line down the equal sign, we're going to identify our like terms. And in this case, they both are x's, and they're side by side. They do not always have to be side by side. But we're going to go ahead and put those together. Negative 2 plus 8 is a positive 6x. Then we're going to just drop down everything that's not highlighted because we didn't do anything with it. And that step is called combining like terms. Now, step number 2. We are going to move this negative 3 to the other side. The opposite of a negative 3 is a positive 3, so that's why I'm adding 3 to both sides. So step 2 would be add 3. When I do that, negative 3 plus 3 is 0. So I'm going to just drop down this 6x, and that's going to be equal to 48. Now, my next step is to get the x by itself because there's only one step left. And in order to do that, I'm going to divide by 6. The reason I'm dividing is because right now 6 is being multiplied by x. So I'm going to divide by 6 on both sides. That gives me x is equal to 8. Again, to check your work, all you have to do is plug it in. Negative 2, everywhere you see an x, you're going to write parentheses. And that's supposed to be equal to 45. Now, again, our x's up here you always plug into the original equation. Your x's were 8. So I'm going to plug that in. Now, using Desmos, I'm going to type it exactly as I see it right here. And I'm just going to cover up this equal 45 because I'm not typing that in. So negative 2, parenthesis, 8, close my parenthesis, plus 8, parenthesis 8, minus 3. It's equal to 45. Looking at our original problem, it was supposed to be equal to 45, so then I know I've got this problem correct. All right, moving on to the next problem, example number 8. We have negative 2 times the quantity 5x minus 1 minus x equals 24. We're going to draw a line down that equal sign, and this time you got to get rid of the parentheses first, so the first step we're going to do is to distribute. And we are going to distribute negative 2. So negative 2 times 5x is negative 10x. And negative 2 times negative 1 is a positive 2. And then I'm just going to bring down everything I didn't touch. Minus x equals 24. Now, to combine like terms, this time my like terms are negative 10x and negative x. So when I look at that, negative 10x minus 1x is simply negative 11x. Then I'm just going to drop down everything that I haven't touched. So that's the plus 2 equals 24. And when I did that, that step is called combining like terms. Now, the next step, step number 3, I got to get rid of this plus 2. To get rid of plus 2, I'm going to subtract 2 because the opposite of plus is minus. When I subtract 2, positive 2 minus 2 is 0. I'm now left with this negative 11x is equal to 22. Now remember what our goal is. Our goal is to always get that x by itself. So now I'm going to get rid of the negative 11. In order to get rid of the negative 11, it's being multiplied. So I'm going to divide by negative 11. So that's step number 4. Divide negative 11. When I do that, I get x is equal to negative 2. Remember to watch your signs. A positive divided by a negative is a negative. Remembering that you must check your work in order to ensure that it's correct. But remember, every time you plug in a number, you have to use parentheses. And it's supposed to be equal to 24. We found all of our x's. I'm plugging it into the original, was negative 2. So I'm going to write that down. Again, when I plug this in Desmos, I do not type in equals 24. Instead, I'm just going to see if it equals 24. And I'm going to type in everything else you see here. Negative 2, parenthesis, 5, parenthesis, negative 2, close my parenthesis, minus 1, close my parenthesis again, minus, parenthesis, negative 2, closing my parenthesis. It's equal to 24. And if you can see here, it is supposed to be equal to 24, so I know I've got it right. And that's a quick, easy way to make sure you're going to get a 100% on your test. All right, so the very last section, it says, what does it mean to be a consecutive integer? Remember, consecutive means one right after another. So an example of a consecutive integer would be something like negative 3, negative 2, negative 1, 0, 1, 2, 3, so on and so forth in both directions. All right, those are consecutive. One comes right after the other. Consecutive odd would be like negative 5, negative 3, negative 1, 1, 3, 5, 7, so on and so forth in both directions. Consecutive even, you guessed it, it's going to be your even numbers, negative 6, negative 4, negative 2. 0 is actually even, 2, 4, 6, and it keeps going. So just so you know what consecutive odd and a consecutive even are, I put them there, but we're going to be talking about consecutive integers. It says in the problem, find 3 consecutive integers whose sum is 36. So sum means to add. So I'm going to take one number, add it to another number, add it to a third number, and that's supposed to be equal to 36. Now, hypothetically speaking, let's not even think about algebra. Let's just talk about numbers and forget about the 36. If I have 3, 4, and 5, we're just using small numbers for right now. What do you got to do to 3 to get to 4? Well, all you have to do is add 1 to it. And if I was going from 3 to 5, I would have to add 2 to it. So what I'm getting at here is the thought process. If x is my first number, in this case, my example was 3. To get to my second number, no matter what it was, I'm going to take my first number and then I'm just going to add 1 to it. So x plus 1 would give me my second number. No matter what that first number was, if we let that represent a variable x, to get to the next number, we just add 1 to it. To get to my third number, in this case, in this example, it was 5. I got to think, what do I got to do to 3 to get to 5? And we just talked about that. It was 3 plus 2 gave us 5. So we know we have to add 2. And again, if 3 was an unknown number, we would say that would be x. So then x plus 2 would get us to that third number, no matter what number x is. So we're going to use that thought process and define our variables in this let statement. So we're going to let x equal first number. And remember that hashtag symbol means number. We're going to let x plus 1 equal the second number. And last, we're going to let x plus 2 equal the third number. So to write the equation to fit this problem, we've kind of got it set up here. But now let's put our variables and numbers in it. We have x, and then we're going to say plus. That's the first number. The second number, which was x plus 1. I'm trying to color code this so you can see it. Plus the third number. And in this case, the third number was x plus 2. That is going to be equal to, in this case, 36. Now, to solve the equation, this equation right here, we're going to combine like terms. Our like terms are our x's. So we have 1x plus 1x plus another x. That gives us 3x's. So 3x. Now our constants are also like terms. So this is a positive 1 plus 2. So 1 plus 2 is 3. So I'm going to say plus 3 is equal to 36. Now it looks like a normal two-step equation. Although here it did look very large, it really breaks down to something rather small. So to solve this, we are going to use the subtraction property of equality and subtract 3 on both sides. That gives me 3x is equal to 33. Dividing by 3 on both sides, x is equal to 11. Now, it's wanting you to find 3 consecutive integers. So my first number is 11. If I take 11 and add 1 to it, it gives me 12. And if I take 11 and add 2 to it, 11, 12, 13, it gives me 13. So these are the 3 numbers that are our solution. So that way, they're consecutive integers, 11, 12, 13. And this is the thought process behind that. I hope today has given you a better understanding of using the distributive property and combining like terms in order to solve multi-step equations. Have a fantastic evening.